in the last slide yesterday.
Oh yeah, 'cause PSI.
And the solids, we said the particles are close together, so you can't squeeze the particles any closer. The particles don't move from place to place. Means the solid has a definite shape and doesn't change. Lizzie, let's back up your spot and pay attention here. Madison.
How come you can't feel the tables like that?
Okay, it's a good question. We said in kinetic molecular theory that it's the idea that everything is made of moving particles. And we said that in the solid tabletop that you don't feel it. And the reason for that is because the particles are too small. There are, in the spot that you're touching here, there are billions of different particles. And their vibration is so small, in such a short distance, you don't feel it at all. Good question. Okay, the last thing from yesterday. Last thing from yesterday was the pressure units. When we talk about gases, like the air in this room, those gases have pressure. Did you guys finish this slide yesterday?
Yes, we did.
All right.
Okay, can I borrow a pencil?
If you didn't, you should finish it right now while I'm talking about it. All right, so pressure. This was the last from yesterday.
Oh, is this the last of all the ones?
No, we've got notes today. So, be finishing these up if you're not done.
I'm done.
You done?
I'm
Okay.
done.
Okay, first of all, there are many different pressure units. There's even more than what we have listed here. The first one listed is PSI, and that stands for pounds per square inch. Would you stop talking, Brian? And so pounds per square inch means in a square inch of area, there is that many pounds of force. So for example, if you have a bicycle tire and you pump that up to a pressure of 30 PSI, that means on 1 square inch of the inner tube on the inside of that bicycle tire, there is 30 pounds of force on that 1 square inch.
I've heard that before.
Would you stop talking?
Jeez.
All right? So that is 1 pressure unit, pounds per square inch. If you look at a car tire, there's printed into the rubber there a number that it suggests that you put that much pressure in. So maybe 30, maybe 40. It depends on the tire. Okay, the second unit is called a Pascal. I don't think we got to that as far as discussing it yesterday. A Pascal is a metric unit. The pounds per square inch, of course, is English system units. It's what we use more often in the United States. But a Pascal, then, it's also a force in an area, but it's newtons of force and meters squared per area. How does a meter squared compare to the size of an inch squared?
7 meters on it.
And it's much bigger, right?
No.
A meter squared, if we take a look at this meter stick, it goes down that far, over this far, and so this area right in here is about a square meter. An inch square would be about the end of this. So that size compared to this whole size here, you can see that a square inch is much smaller than a square meter. In other words, there are many pascals in every PSI. So a pascal is a very small amount of pressure. There's 101,325 pascals in 1 atmosphere, and there's 14 pounds per square inch in 1 atmosphere. So the difference between 14 and 101,000 is very large. So the sizes of the units are very different. Because of that, if you look at your car tires at pounds per square inch, and it says it's 32 pounds per square inch, they want you to put in there a pressure. Instead of pascals, the metric pressure will be given in kPa. And so you'll have PSI for the English units of pressure, and you'll have kPa, kilopascals, for your metric unit for pressure. Okay, the third unit of pressure here is called inches of mercury. Hg, you remember that from those 30 elements that we learned the symbols for. Hg was mercury. And so inches of mercury, this is in a barometer, which is a glass tube, sort of like a test tube, that's in a dish of mercury. When the pressure goes up, it's going to push that mercury higher in the tube. The pressure goes down, the mercury level will fall. So when they say the barometer is rising, when they talk about that on the weather, that means the atmospheric pressure, the air pressure, is going up. That means the level of mercury in the barometer is going up. And they use that atmospheric pressure to predict the weather. All right, so air pressure in the atmosphere is affected by changes in weather patterns. All right, so inches of mercury is a pressure unit for mercury in a mercury barometer. Okay, number 4 is ATM. You got 20 more minutes, Josh. We don't throw stuff in here.
Wow.
Eric, be quiet. Okay, the last one for pressure units listed here is ATM. And ATM stands for atmospheres. We just talked about the weather in the barometer, and we said that the weather changes with the changing in pressure. Eric, get it out of there. Leave other people's stuff alone. All right? Eric, don't touch her stuff. All right? And so atmospheres, ATMs, you got it out, is the normal atmospheric pressure. But, of course, that can change. If there's going to be a hurricane, maybe it'd be a much different barometer reading. Okay, that finishes up yesterday's. Now we have today's. That was 11-2. Today we are on 11-3. It's May 21. Hey, you do not need to clap.
So you're my teacher. Oh, why do you have this book? Remember when I got that assignment?
I should have
Okay,
no
oh,
pencils
we
tomorrow.
got it.
Good.
Good job.
No, I have to do my good.
Okay, it is May 21, notes 11-3. When we're done with this, if there's time, we'll go over those bones again at the quiz tomorrow.
I thought you were gonna say it to go to the park. Look, I'm in it.
No.
Just looks
I wish.
Look, I'm in a missile.
More about pressure. Start writing.
Whoa! Don't yell.
Victor.
Like that. Whoa! That's
Eric,
a
if it's
missile. This is in diff. What's that? 7-2.
3. Victor, get some paper.
Chloe.
Oh yeah, I put that in there.
I know.
Get busy writing. You know what you're supposed to do. Eric, you're talking too much.
doctor said that he died. I think it's just for them being
Wee.
No, you just killed that thing. You just killed it. Is that particles?
That is part of
You
it.
killed that thing like roadkill on a dead dog. King buffet? Man. I don't know, that looks good.
Let's go.
You talk about it now, so.
Go build the ender. Go build it.
If you're done, just wait quietly. We're gonna wait till Garrett's back before we talk on this. Just move your luggage over.
What?
Okay, Garrett's back. We're gonna talk about the pressure and the moving particles here. Okay, the pressure units that we talked about, ATM, PSI, millimeters of mercury, and so on, atmospheres. That pressure depends on the movement of the particles of gas. We don't think about that moving much because we don't see them, but the example we gave earlier about the perfume in the air, we know that the particles move because when you spray that perfume, pretty soon you can smell it in other spots. So we know that the air particles are moving. We also know that because we can feel the wind as the air particles move with the wind, and we can see what effect that has if it blows the leaves and the trees and so on. The pressure then depends on the moving gas particles. And that pressure is affected by three things. First of all, the temperature. If you have a sample of a gas, for example, if you have a tin can, an aerosol can, and you throw that can into a burning barrel, into a fire, what's going to happen?
Your dog's gonna die.
Okay, it's going to blow up, right? Because as the temperature in that fire goes up, the pressure in the can, the air pressure, is going to go up also. So temperature and pressure vary directly. If the one goes up, the other one's going to go up too. Okay, the second thing is the volume. The volume and the pressure are opposite varying. We say that that's an inverse relationship. If you have a bubble wrap packaging and you squeeze on that, as the volume goes down, the pressure goes up. In fact, if you squeeze it small enough, it's going to pop that open, split the sides of the air bubble that you've got in that bubble wrap. All right, so volume and pressure very opposite. If the volume gets smaller, you squeeze it smaller, then the pressure is going to get bigger. And the third thing is the number of particles. If you have your car tire and you want more pressure in that, the way you do that is by pumping the tire up. You add more air particles.